This lesson, we're going to learn how to do optimization involves trigonometry functions. Example 1. Given a trig function cos square x on the interval between 0 and 2 pi, we want to find the maximum and minimum value. So step 1, we have to find the first differentiation and let it equal to 0. Since the exponent is in the middle of the cosine and the x, that really means the whole thing square. That means when you do the differentiation, you bring down exponent take away 1, and differentiation of the cosine, which is negative sine x. And you can see this is negative 2 sine x cos x, which is the double angle formula, negative sine 2x. And then we let the first differentiation equal to 0 to find the critical points. So we will have 0 equals a negative sine 2x, which means 0 equals a sine 2x. Before we can find the angle, we have to modify our domain. Because our angle becomes 2x, that means 2 times bigger. So our domain will become 0 less equals to 2x less equals to 4 pi. Basically means you times every single interval times by 2. We know the sine value means the y value. So according to the unit circle, when the y value becomes 0, will be this point and this point. Therefore, we will know our angles will be at 0, pi, 2 pi, 3 pi, and 4 pi. However, that's 2x. So in order to get x, we have to divide every single angle by 2. So x will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are all our critical points. Now, let's identify all the critical points that we have. So put it on the number line for f prime and put the critical points on and check the positive negative sign using f prime. And you will get positive, negative, positive, negative, positive, negative. What does that mean? That means increasing, decreasing, local maximum. Decreasing, increasing, minimum. Maximum, minimum, maximum. And now it's time to find our y values according to every single x value here. So you have to substitute back into the original function to find the y value, and you will get all the local maximum will be at 1, all the local minimum will be at 0, and the endpoint is actually the local maximum as well, which is 1. Therefore, we know this is the absolute maximum, and this is the absolute minimum. Therefore, we say the minimum value is at negative 1 and the maximum value is at 1. Example number 2, a particle moves along a line. So the function is given by s equals 4 sine 4t. A, when does the particle change direction? The direction of the movement can be found by using the velocity time function. If the velocity time function is positive, means the object is moving forward. If the velocity time function is negative, that means the function is moving backwards. So first, let's find the first differentiation, Vt. 4 is the coefficient, so differentiation sign is cosine, copy down the angle, times by differentiation angle, which is 4. So you're going to have 16 cosine 4t. Then we let Vt equal to 0 to find out all the zeros for the velocity. So we get 0 equals to 16 cosine 4t. And according to the unit circle at those 2 points, cosine value will be 0. So we know our angle 4t will be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. Then we're going to divide every single number by 4 to get the time. As you can see here, we only use positive t values because time can never be negative. After that, put all the critical points on the number line to check the positive negative sign and make sure the boundary starts at 0 because time is greater or equal to 0. And you will see increasing, decreasing, increasing, decreasing, increasing. So that means at those zeros, those are the times that we change the direction. Therefore, the particle changes direction at time equals 2 odd number pi. Odd number means 2 times by n plus 1. because 2 times by any number will be even, plus 1 will be odd, and pi over 8. And we have to define our n. N is the element of whole numbers. Whole numbers means start with a 0 and then becomes 1, 2, 3, 4, and so on. Part B, we want to find the particle's maximum velocity. So method 1, maximum velocity occurs when the acceleration becomes 0. The acceleration function can be found by differentiating the vt function. So coefficient 16, copy it down. Cosine becomes negative sine, differentiation angle, which is 4. Then we get a new function, negative 64 sine 4t for acceleration. And then we let it equal to 0 to find the critical points, which is 0, pi over 4, pi over 2, 3 pi over 4, and pi, and so on. Then we put the critical points on AT to check the positive negative sign. You will see the maximum will happen at pi over 2, pi, 3 pi over 2, and so on. And we check the velocity value at that time. And it doesn't really matter which local maximum you pick, you're going to get 16. Method 2, we're going to use the properties of trig to find the maximum velocity. As we know, the maximum value for cosine and sine is always 1. As you can see from this diagram here, cosine 4t, the maximum y value is always at 1. Therefore, the maximum velocity will become 16 times by 1, which is 16. Part C, we want to find the particle's minimum and maximum distance from the origin. Method 1, we're going to use the differentiation. Let the velocity equals to 0 to find the critical points, and then we put it on the number line to check the positive and negative interval to identify each critical point as a maximum or minimum. After that, we know there's a maximum at pi over 8. We substitute back into the displacement time function. We get the distance, which is 4. At the same time, we know the minimum is at 3 pi over 8. We substitute 3 pi over 8 into the displacement time function. We will get the distance is negative 4. Method 2, we're going to use properties of trig again. So we know the displacement time function is 4 sine 4t. And we know the maximum for sine function will be at 1, and minimum for sine function will be at negative 1. So we say the maximum displacement will be 4 times by 1, which is 4. And the minimum will be 4 times by negative 1, will be at negative 4. Example number 3. An irrigation channel is constructed by bending a sheet of metal that is 3 meters wide. What angle theta will maximize the cross-sectional area? Since we are optimizing the area, so our equation will in terms of the area of the shape, which is a trapezoid. That is top plus the bottom times by the height divided by 2. Let's label the diagram. First, I draw a height. I label them y. And this side, I'm going to say that's an x. Then the top of the trapezoid can be written as 2x plus 1. And the base will be 1, the height will be y, and that's substituted into the equation. Now we will have 2x plus 1 times by y divided by 2. And the first bracket can be simplified to 2x plus 2 by collecting the like terms, and we can common factor out the 2, and we can have a very simplified version, x plus 1 times by y. However, in order to do optimization, you cannot have more than one variable in the domain. That means we have to replace them. That means we have to go back to our diagram to see what we can replace x and y with. As you can see here, this is a right triangle, so we can use the primary trig ratios. Cosine theta is adjacent over hypotenuse, which is x over 1, so we know x is cosine theta. And sine theta will be opposite over hypotenuse, which is y over 1. That means y is sine theta. Then we can rewrite our equation in terms of the theta. So we say area equals to cosine theta plus 1 times by sine theta. before we differentiate, we have to find the restriction for the domain theta. So let's go back to the diagram again. We know we are bending the sheet of metal to make a channel. That means this line can bend inwards and this line can bend inward. The maximum they can bend will become a equilateral triangle. That means the maximum angle theta can be will be 120 degrees. And the smallest value theta can be will be 0, but not equal to 0. Because if it is 0 degree, you're going to have a flat line. You don't have a channel. Therefore, we say 0 degree less than theta less equals to 120 degrees. Now, let's use product rule to differentiate it. So we're going to have a prime equals to differentiation cosine is negative sign. Constant becomes 0 plus cosine theta plus 1 times by differentiation sign, which is cosine. And that's simplified by expanding it. You get negative sine squared theta plus cos squared theta plus cosine theta. And we know sine squared is 1 minus cos squared. So negative sine squared will become cos squared minus 1. And collect the like terms. And factor them. Now we are ready to find the zeros. Let a prime to be 0 to find the critical point. Then we get 0 equals to 2 cosine theta minus 1 times by cosine theta plus 1. So we know cosine theta will be half. That means theta will be 60 degrees. And cosine theta will be negative 1. Theta will be 180 degrees. But this is invalid because that's not inside the boundary of the domain. Next, we'll put it on the number line for a prime. So put the 60 degrees on and put your boundary on 0 and 120. Let's check the positive negative sign. You will see this is a local maximum. So local max at 60 degrees. And we have to check with the endpoint, which is at 120 degrees. Let's substitute those theta values into your A to find the area. So we will see the area will become root 3 over 4 for 60 degrees and root 3 over 4 for 120 degrees. So then we can say this is our absolute maximum and this is our absolute minimum. Therefore, the maximum area occurs when theta is 60 degrees. Example 4. An isosceles triangle is inscribed in a circle. Inscribed means it's inside the circle. With a radius r. R, remember, that's a constant. Find the value of theta, which is a variable, that maximizes the area of the triangle. Because we are trying to find the maximum area of the triangle, so our equation will be area equals a half base times by the height. Next, we have to go back to the diagram to help us to find the variables that should be in our equations. So let's look at this circle here. This should be the center of the circle. So from the center of the circle to any points on the circle should be having the same distance because that's the radius of a circle. And then let's look at this triangle here. Because this is an isosceles triangle, so the perpendicular line will be bisect the angle. That means this is angle theta and that's angle theta. And because those two lines are radius of a circle, that means those two are the same. So this makes this triangle an isosceles triangle as well. So if this angle is theta, then this angle will be theta as well. And we know 3 angles in a triangle, they will add up to 180 degrees. That means this angle will be 180 degrees minus 2 theta, and that will make this angle 2 theta. Let's redraw the diagrams only with the variables that we need to find the area of the triangle. So first of all, we need to know the height of the triangle. So we know this side is radius r, then we label this y. And we also need to know the base. So we're going to say this side is x, so the whole base will be 2x. And now we can see the area equation can be modified to a half times by 2x times by r plus y. R is a constant, however, X and Y are two different variables. And in order to do optimization, you only can have one variable. That means we have to go back to our diagram to change X and Y again. As you can see, this is a right triangle, and the hypotenuse, which is the radius of the circle, R. Then I can say cosine 2 theta is adjacent of a hypotenuse. That means y is going to be r cosine 2 theta. And sine 2 theta will be opposite over hypotenuse, which is x over r. So I get x equals r sine 2 theta. Then I can substitute x and y back into the area equation. I will have half times by 2, r sine 2 theta times by r plus r cosine 2 theta. And as you can see, there is a common factor of r in the last bracket. So I'm going to factor out the r. At the same time, half times by 2 is 1. And then I times by the r and the r together. So my area equation can be simplified to r squared times by sine 2 theta times by 1 plus cosine 2 theta. Now we are ready to find the restriction of our domain, theta. So let's go back to this diagram again. Because this is a right triangle, that means this angle is already 90. That means the maximum angle 2 theta can be will be 90 degrees, but not equals 90. Otherwise, you don't have a triangle. At the same time, the minimum for 2 theta will be 0. So then you will have 0 less than 2 theta less than 90 degrees. That really means 0 degree less than theta less than 45 degrees. Therefore, this is our domain. Since we see there are two functions that are being multiplied together, that means we're going to use product rule. So a prime will be r squared as a coefficient, so leave them outside. Sine will become cosine, and times by differentiation angle, which is 2, times by 1 plus cosine 2 theta, plus sine 2 theta, don't change it, and differentiation of the second function, which is differentiation 1, 0, cosine will be negative sine, and times by differentiation angle, which is 2. Next, let's simplify it. R squared is going to be 2 cosine 2 theta plus 2 cosine squared 2 theta minus 2 sine squared 2 theta. Because we need to find the critical point, then that means we have to factor it. That means we have to change sine squared into cos squared by using the Pythagorean identity. Sine squared equals 1 minus cos squared. After we simplified it and collect the like terms and factored it, then you will get 2r squared times by 2 cosine 2 theta minus 1 times by cosine 2 theta plus 1. And now we are ready to let a prime to be 0 to find the critical point. After we let a prime to be 0, you will see cosine 2 theta equals a half. That means 2 theta can be 60 or 300. But 300 is outside the boundary, so we exclude it. So theta is going to be 30 degrees. At the same time, the second bracket can be 0 too. So cosine theta plus 1 can be 0. That means cosine 2 theta equals negative 1. 2 theta is going to be 180, which is 90 degrees for theta, which is also invalid because that's outside the domain. Now, let's identify our critical points. So we put the 30 degrees on A prime, and we'll put the boundary on 0 and 45. Check the positive negative interval. You will see on the left-hand side is positive, right-hand side is negative. That means this is a local maximum. And you don't need to check the endpoints at this time because it's not included. Therefore, we say maximum area of the triangle occurs when theta is 30 degrees. Example 5, the hypotenuse of a right triangle is given, which is 12 centimeters in length. We want to find the angle theta in the diagram that will maximize the perimeter. First, we have to find our equation. Since we are trying to maximize the perimeter, so our equation will be in terms of perimeter. Perimeter is going to be x plus y plus 12, according to the diagram. Next, we have to change two variables into one variable in the domain. So let's look at the diagram. It is a right triangle, so we're going to use the primary trig ratios. We know cosine theta is adjacent over hypotenuse, so x will be 12 cosine theta. At the same time, sine theta will be opposite over hypotenuse, so y will be 12 sine theta. And we are going to replace x and y with a new domain that we find. So now we can rewrite parameter equation into 12 cosine theta plus 12 sine theta plus 12. Before we differentiate, we have to find the restriction for theta. So let's look at the diagram again, because that's a right triangle, and this angle is already 90. So the maximum angle for theta will be 90, but not equal to 90, and the minimum will be 0, but not equal to 0 degree. So let's look at our domain. 0 degree less than theta less than 90 degrees. Now we have the equation, we have the domain, we are ready to do differentiation. So P prime will become 12. Differentiation cosine is negative sine plus 12 differentiation sine is cosine. Constant 12 will become 0. So you will get negative 12 sine theta plus 12 cosine theta. And then we let P prime to be 0 to find the critical points. And we get 0 equals negative 12 sine theta plus 12 cosine theta. That's add 12 sine theta on both sides. So you get 12 sine theta equals to 12 cosine theta divided by 12 on both sides. Now we get sine theta equals to cosine theta. And then that's divided by cosine theta on both sides. How come we can divide by cosine theta? The reason is theta can never be 90 degrees. That means cosine theta will never become 0. So since cosine theta can never be 0, then we can divide it. Then we're going to have tangent theta equals to 1. Then we can see theta is going to be 45 degrees, which is pi over 4. And you put it on the number line for P prime. Remember to put the boundary down and check the positive negative sign. You will see on the left is positive, on the right is negative, increasing, decreasing. So we're going to have a local maximum at 45 degrees for theta. And we're going to find the endpoints. But since there is no equal sign on the inequality for the domain, therefore not applicable. Therefore, we say maximum parameter occurs when theta is 45 degrees. Example 6. A fence is 1.5 meters high and is 1 meter from a wall. A ladder must start from the ground, touch the top of the fence, and rest somewhere on the wall. Calculate the minimum length of the ladder. First thing, we have to draw a graph. First, let's draw the ground. Next, let's draw a wall. And let's draw a fence. And we draw a ladder. And we're going to label them with the information given in the question. So the fence is 1.5 meters high. So this is 1.5 meter. And it is 1 meter from a wall. So we know this is 1 meter. We want to find the length of the ladder. So we're going to label this X and Y. Then we can find our equation. Length of the ladder, L, equals X plus Y. According to the equation that we have, you can see there are two variables in the domain. In order to do optimization, you only can have one variable in the domain. That means we have to go back to this diagram and try to change X and Y into something else. So we're going to use trigonometry. We're going to put the theta here. And at the same time, if you do a dotted line, which is parallel to the ground, you will see this angle is also theta because they are corresponding angles. Now in this triangle, because that's a right triangle, then we can use primary trig ratios. According to this angle, this is the opposite side, that's the hypotenuse, so we can use sine. Sine theta equals to opposite over hypotenuse. That means x equals 1.5 over sine theta. So we can write x is 1.5 cosecant theta. And the top triangle here, that's also a right triangle. And according to this angle, this side is the adjacent side, which is 1, and this is the hypotenuse, so we can use cosine. So cosine theta equals adjacent over hypotenuse. That means y equals 1 over cosine. That means y is secant theta. Let's rewrite our equation in terms of theta. So L equals 1.5 cosecant theta plus secant theta. Then we're going to find the restrictions of our domain, theta. Because it is a right triangle, that means this angle is already 90. That means the maximum angle that theta can be will be 90, but not 90 degrees. Same thing, the minimum will be almost 0, but not 0 degree. After we have the equation with only one variable in the domain, and we have the domain, then we can differentiate. So L prime will be negative 1.5 cosecant theta cotangent theta plus secant theta tangent theta. Then we're going to let L prime to be 0 to find the critical point. So 0 will be negative 1.5 cosecant theta cotangent theta plus secant theta tangent theta. Now, move the negative to the other side of the equal sign, you get positive. Now we have to switch all the secondary trig ratios into the primary trig ratios in order to solve. So this will become 1.5 cosecant is 1 over sine theta. Cotangent will be cosine theta over sine theta. Secant theta is 1 over cosine theta. And tangent is sine theta over cosine theta. And then we're going to cross multiply. Then we're going to get 1.5 cos cube theta equals to sine cube theta. Because the domain for theta is between 0 degree to 90 degrees, therefore cosine theta will never be 0 because theta is never 90 degrees. Then we can divide it by cosine cube theta on both sides to get tangent cube theta equals to 1.5. In order to isolate tangent theta, then we're going to do cube root on both sides. So say tangent theta equals cube root of 1.5. Then theta is going to be tangent inverse of cube root of 1.5. Then you will see on the calculator, theta is approximately 48.86 degrees. Next, let's identify the critical point by putting the critical point on the number line for L prime. And remember to put the domain down, 0 and 90 degrees. And let's check the positive negative sign. On the left hand side is negative, on the right hand side is positive, means decreasing, increasing. So we have a local minimum at 48.86 degree. And we're going to check with the endpoints, which is not applicable because there's no equal sign on the inequality. And let's substitute the angle 48.86 degrees back into the length equation. Then you will see the value is 3.51. Therefore, minimum length of the ladder is approximately 3.51 meters at the angle 48.86 degrees. Example number 7 is very similar to example number 6. However, this time we are carrying a pole that we need to turn around the corner. Let's define our equation. Since we're finding the longest pole, so our equation will be in terms of length of the pole. So length equals to x plus y. Next, let's switch the variable x and y into one variable in the domain. So we know cosine theta equals adjacent over hypotenuse. So x equals to 1 over cosine theta. So x equals to secant theta. And we know sine theta equals the opposite of hypotenuse, which is 0.8 over y. That means y is going to be 0.8 over sine theta. So y is 0.8 cosecant theta. Let's rewrite our equation. L equals to secant theta plus 0.8 cosecant theta, and let's find the domain. Since theta is in the triangle and this angle is already 90 degrees, so once again, theta can only be in between 0 and 90. Once you have the equation and the domain, then we can find L prime. Secant will become secant theta tangent theta, and cosecant theta differentiation will become negative cosecant theta cotangent theta. And after we differentiate it, we're going to let L prime equal to 0 to find the critical points. After we substitute 0 into L prime, then we move the negative 0.8 to the left-hand side to become positive. And that's switch every single trig function into sine and cosine. So 0.8 is 0.8 over 1. Cosecant theta is 1 over sine theta. Cotangent theta is cosine over sine. Secant theta is 1 over cosine. Tangent theta is sine theta over cosine theta. After that, we're going to do a cross multiply. Then you're going to get 0.8 cosine cube theta equals to sine cube theta. In order to solve for trigonometry functions, you cannot have two trig functions. That means we have to switch them back into one. How do I do that? I'm going to divide by cosine cube theta on both sides. The reason I can do it is because theta, it's never at 90 degrees. That means cosine theta will never become 0. Therefore, we can divide it by cosine cube theta on both sides. And once we divide it, you are going to get 0.8 equals tangent cube theta. In order to isolate for tangent theta, we have cube root both sides. Then we take tangent inverse of cube root of 0.8 to find the angle theta. And theta is going to be approximately 42.87 degrees. And put the critical points on the number line for L prime to identify whether or not this is the maximum minimum. And remember to put your boundary on. You will see on the left-hand side is negative, on the right-hand side is positive. So this is a local minimum. Now we know there is a local minimum at 42.87 degrees. So we substitute back into the length equation. We will see the length will be 2.54. And we have to verify with our endpoints. But since there's no equal sign on the inequality, so the endpoints are not applicable. As you can see, even though we are looking for the longest pole, mathematically it says this is actually a local minimum. The reason is this answer originally shouldn't have any boundaries around this. So therefore, this is a so-called a special case. Even though mathematically this is a local minimum, but according to the context of question, because being bounded by the wall, this is actually means the maximum length of the pole that we can have. Therefore, we say the longest pole that can be carried is approximately 2.54 meters at the angle approximately 42.87 degrees. Example number 8. When the rules of hockey were developed, Canada did not use the matrix system. Thus, the distance between the goal post was designated to be 6 feet. If Sidney Crosby is on the goal line, 3 feet outside one of the goal posts, how far should he go out to maximize the angle in which he can shoot at the goal? In other words, that means how far he needs to go out in terms of length of x, such that he will have the maximum angle that he can shoot at the goal. Since we need to maximize the angle theta, then our equation is supposed to be in terms of theta. So let's look at the diagram closely. You can see theta, it's not in a right triangle, and all the primary trig ratios require a right triangle, so we're going to look at the angle differently. So first, I see a big right triangle right here, and I'm going to define my angle alpha. It's this angle right there. And then I look at another right triangle, which is smaller one. Then I will say this angle is going to be my beta. And then we can say my theta will become alpha minus beta. In addition, we know this side is the opposite side, and this side is the adjacent side to the angles here. Therefore, we're going to use tangent in this question. Since theta equals alpha minus beta, then we say tangent theta equals to tangent alpha minus beta. Then we're going to use the compound angle formula for tangent A minus B. So tangent alpha minus beta will become tangent alpha minus tangent beta over 1 plus tangent alpha times by tangent beta. And let's look at tangent alpha. Tangent alpha will be opposite side, which is 9, over the adjacent, which is x. And tangent beta will become the opposite side, 3, over the adjacent side, x. And let's put those two ratios into our equation. Next, we're going to combine those two fractions because they have the same denominator. And then we're going to multiply those two fractions into one single fraction. After that, we are going to combine those two terms into one fraction, and we're going to change this into a division symbol. Then we're going to change this division into multiplication by multiplying the reciprocal. Finally, we're going to have a very simplified function with only one variable in the domain. So now we're going to find the restriction for the domain, x. Since x is distance that he goes out, so x has to be greater than 0. Now we have the equation, we have the domain, we are ready for differentiation. So we're going to differentiate tangent. Tangent will become secant squared theta, and d theta over dx equals 2. That becomes a quotient rule, x squared plus 27 whole thing squared. Differentiation numerator, which is going to be 6, times by the denominator, minus the numerator, times by differentiation denominator, which is 2x. Let's expand and simplify the numerator on the right-hand side of the equal sign. You will get negative 6x squared plus 162 over x squared plus 27 whole thing squared. Now, let d theta over dx equal to 0 to find the critical points. Then we get 0 equals to negative 6x squared plus 62 over x squared plus 27 whole thing squared. And to multiply by the common denominator on both sides, then we're going to get 0 equals negative 6x squared plus 62. Bringing the negative 6x squared on the left-hand side, you get 6x squared equals to 162. Divided by 6 on both sides, you get x squared equals to 27. Square root both sides to find our x. So x will become 3 square root of 3, or x will become negative 3 square root of 3. And the negative is invalid because that's not within our domain. So let's classify it, identify it by using the d theta over dx. And let's put a critical point on and make sure you put a boundary on. That check the left-hand side is positive, and check the right-hand side will be negative. So going up, coming down, this is a local maximum. Because there is no equal sign on the inequality in the domain, therefore we say the endpoints are not applicable. Therefore, he should go out by 3 square root of 3 feet to have the maximum angle to shoot at the goal.